We're always having, there's always things to learn. Not today. Not today. We've got a couple of toy activities coming up. We are, but not today. It's not, you don't know enough yet. You have to know enough. You don't know enough yet. But when you know enough, we will cut you loose. Today you're gonna have all right. Isabel in the waiting room. Hey crew, how we doing? All right. So I understand there was a problem with the homework turn-in. And it said something like there is a turn-in, but it's not available. No way to submit. Submission type none. Okay, hold on a second here. Oh, no submission. Wild. So I know this is going to sound like a lame excuse, but I spent Saturday, a couple hours putting all this stuff together, typing up lesson plans, and I don't think I hit save. I'm going to say that I hit save, and I didn't, but that's probably a lie. I probably just didn't hit save. So it should be good now. Try it. Try to see if you can upload it now, if you don't mind. All right. Crew. Oh, Sam is in the waiting room. Da-da-da. There he is. Nope, 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 yep. Ah, there are. All right, Zoom crew, can you see my iPad screen? Is that good? Oh my God. Every day. Why do we have this conversation every day? It's always the same. All right, hold on. Nora's laughing at me. Say hi to your friends. Hey. All right. Let's see if we can make this happen. Can you see it now? Okay, good. Thank goodness. So you know what? Like technology is a great equalizer. And I remember when I was a student and teachers would be standing up there and they'd be trying to figure out stuff. And I'm like, oh, poor old people. Like, look at those poor old people. Super condescending of me. And now that I stand up here, I realize like, you guys are probably like, oh, he probably doesn't even know what Snapchat is. It's fine. All right. It's fine. We're here. We made it. All right. So I hope you had a good weekend. Did you have a good weekend? For those of you playing along at home, Miller had a good weekend. Did you have a good weekend? Mara was not as convinced. It was not as convincing. Her nod was sort of like, yes, yes. Did you have a good weekend? Yeah. Okay. Odita gives it a solid 7, which, you know, that's something. All right. Daniel, did you have a good weekend? Okay. Hey, I wrote your Eagle recommendation letter. I should have sent you. Did you see a copy of it? I should have sent you a copy. Eagle Scout recommendation letter. Yeah. So he will be. He will be. So I love writing those because I'm an Eagle Scout. Did you know that? I'm an Eagle Scout, so I enjoy writing them. No, it's Boy Scouts. Boy Scouts. That's right. That's absolutely right. All right, so hopefully I get a chance to connect with each of you about your weekend, but here we are. So what are we talking about? So Sarah asked if we were going to drop Barbies off of a balcony. Not today. Okay, not today, because we're not quite there yet. Today is actually going to be a very, very important step into making the prediction about how many rubber bands you attach, so the Hulk doesn't smash his forehead on the ground. What are we talking about, though? Somebody sum it up for me. Linear regressions. What is that? Lines that regress. Scatter plots. Barbies. Correlations. Weak and strong. Duff's analyses. Yes. So we're taking data and we're asking the question, how linear is it? And we're assigning that a value, an R value, right? And the R value, what can the R value tell us? What's one thing that the R value can tell us? What's one thing the R value can tell us?
How linear it is.
How linear it is. What would be a good linear, a good number to help us with linear? I'm not. All right. Thanks, everybody. All right. What's a good R value to tell us? It's a pretty liney line. 1. Are we ever going to get to 1? I mean, we could, but we're going to have some hot. You guys are so distracted by that popping up. Look at who's trying to get in late. What about a -1? What does that mean? Yeah, it's going in the opposite direction. So it would be a negative correlation. So as the explanatory increases, the response decreases. Okay, so that's what we're looking at today in a little bit more depth. So here we go. Here's the data from one of the groups. The group forgot to record their measurement for 5 rubber bands. Okay, so I would like for you to do this in your calculator. So don't use Stafflet.com. Enter this data into your calculator, please. So use your TI product. So use your calculator to put in this data. I'm going to do the same. So what do we hit first to put in data? Stat. We're on how safe is Barbie? Okay, go down. Go down. So as a reminder, you can go up to the top. You can hit clear and enter, and it'll clear the whole list. Okay. So what do we do for the blank? If we don't have both pieces of data, what should we do? Skip it. Don't put in 0 because that is data. Just don't put in 5. Just don't put the 5 in. So if you're missing that data, so normally we don't have data that goes up regularly like that, like 0, 1, 2, 3, 4, 5, 6, 7. We have an array like 0, 3, 5, 8, 9, 11. So just skip the 5. Don't put the 5. Yeah, so hit this key right here. So you don't want to hit the delete key when you're up on the L. But for an individual element, you can hit the delete key and it'll delete just that one. So like if I go here to 3, or if I go here to 7 and I hit delete, 7 goes bye-bye. So 0 is 25, 32, 41, 49, 55. Okay. Oh, Sarah, thanks for submitting your homework. So what do we do with this data now? They're asking us to calculate a least squared regression line. A least squared regression line. What we're going to do is go out, so hit second quit. So second quit, we'll take you to your home screen. And we're going to calculate a linear regression. So you're going to hit stat. You're going to hit calc. And we're going to go down to linear regression, not natural log regression. Linear regression, A plus BX. Okay? So in all likelihood, your calculator does not look like mine. Yours is going to say something like X list, Y list, frequency list, like freq, F-R-E-Q list. Do any of you have this older model calculator? Got it, okay? So basically, what the new calculator does is exactly this, except this is computer programming language. So it tells you need to put in the X list, comma the Y list. It's going to default to list 1, list 2. So we can just actually hit enter. So go ahead and calculate that. This is the least squared regression line, also known by a lesser known name of line of best fit. So what are we going to write? Well, go back to your notes. A couple of things. We're going to write this. We're going to write a Y with a hat over it, or a caret. So you're going to put a Y with a hat over it, and we'll talk about what that means in just a minute. Yeah. Is it working or no? Okay. So Y hat, very important. And then we're going to write it like this: 25.3333 plus 7.464x. I want to interpret this. This is one of the places where students get a little bit stuck. What does this actually mean? What did we just calculate? Well, Y hat is a special notation in statistics that means this. Oh, Miller, thanks for your submission on your homework. When you see that Y with the caret over it, it's Y hat. And what it means is that's the predicted Y value. So Y hat means predicted Y value. So think about what we just did. We just took data that we know, and we used it to construct an equation to calculate what? Distance traveled for what? So based on the number of rubber bands, like how many rubber bands can we put in here? You could put 1 million in it and you can figure out how far it's going to travel. Do you see how this unlocks unlimited power? Now you can predict anything. You can predict anything. Now, how accurate is that prediction going to be? We'll talk about that. But for now, let's rewrite this equation a little bit. So really what this means is if we put it in context, distance, and I'm going to put a big fat hat on there. So predicted distance is equal to 25.3333 plus 7.464 times rubber bands. I'd like for you to work on 2, 3, and 4 with a partner. So work on 2, 3, and 4. So I want you to predict. So remember, they left out number 5. I want you to predict. Number 3 says they found it. They found it. How far off was it? Too high or too low? And then I want you to predict with 20 rubber bands. So work on numbers 2, 3, and 4. What I get? What? Oh, good question. Right here. For my data. A and B. Yeah. Hey, did you guys see that? Did you guys see what I was pointing to up here? So the values come from our data on our calculator. So the A is 25.33 because that's what our calculator spit out, and then our B is 7.464 because that's what our calculator spit out. That's where we get our predicted values. Okay, go into your breakout room and you guys can talk about that question. Those 3 questions. Yes. That's why we rewrite it, so you can make sure you know. There's a way to do it, but it's not that easy. So the short answer to your question is yes. Hey, what's up, guys? What you got?
Mr. Sarah,
Yes.
could you stay a couple minutes? I just have some things to talk to you.
Stay a couple minutes. What?
Could you stay a couple minutes on Zoom after class? I have something to talk to you.
Yes, I might have to put you on pause because I gotta go. I'll have to release for lunch, but we can talk. Yeah. Yep. Are you guys all done? Good to go? Okay. All right. So how did you do it? How did you predict the 5 rubber bands? Plug it in. So what'd you get? 62.653 is what I got. So what you got? Do you think that's a pretty reliable prediction? Okay. So then it says one of the groups got some actual data. Now, that's why Y-hat is so important. It's not actual data. It's not. It's predicted data. Is it close? Yes. Is it exactly accurate? No. If you dropped 1,000 Barbies, a million, if you dropped 1 million different Barbies with 5 rubber bands, do you think you'd ever get 62.653 exactly centimeters? Probably not. I mean, maybe in a million, but probably not. That's why it's a prediction. It's close. So then the actual data was 1.347, too low. Okay. This is what we call residual. Write this in the margin. The residual, it's RAP, R-A-P. Residual comes from the actual data minus the predicted. Okay? The actual data minus the predicted. You can actually find the residual for every single data value in this chart, couldn't you? So if I have this actual data, could I put in 0 rubber bands and predict what I think it should have been? What would it be? So I put 0 in for X. What would it be? 25.333333. So even though I have actual data, I can do it predicted for that. I just get a residual. Okay. So then for 20, I think you guys are picking up the gist of this. I got 174.613 centimeters. Do you trust this more or less than the 5? Miller gives it a hearty thumbs 3/4 of the way down. Yeah.
I trust it less because there are no solid data points that are close to it.
You are correct. Less. It is far away from known data. Okay, here's a for example. Ready? Zach, this one's for you. So let's say Aaron Judge comes up, and in his first major league at bat, he hits a home run. And someone goes, hey, he's going to hit a home run every single bat of his major league career. 100% of the time, he hits a home run. Is that true? No, we know that's not true. Okay. What if he hits 5 in his first 15? 33% of the time, he hits a home run. Pay him. Because if he has 3,000 at bats, guess how many home runs we got? 1,000. New king. Right? We know that's not true. Does anybody know what it's called when you make outlandish predictions based on minimal data? Dumb? Yes. It's called extrapolation. In statistics, extrapolation is not a good thing. It's where you take data that's over here to make a prediction about something that's way over here. So that's extrapolation. So let's do a flashback to Algebra 1. What is the y-intercept of this particular equation? Yeah, it's 25.3333 centimeters. What does it mean? Yes. So let's do a little fill in the blank here. When we use 0 rubber bands. The distance traveled is 25.333 centimeters. You really need to make sure you understand what the Y context means, because the Y context is always if your explanatory variable is 0. Okay? So I like to label this. So this is going to be in this blank goes x equals 0, meaning the y-intercept is where x equals 0. So whatever x context is 0. And then down here is going to go your y-intercept. Like a lot of things in stats, it's a fill in the blank, but it's to help you have a framework to talk about this. All right. So this, I'm sorry, should say predicted. Make sure you add that. It should be the predicted distance traveled is 25.33, because this is all based on our predictions. Apologies on that. Last question. What is the slope of the equation of the regression line? Algebra 1. This is a slam dunk. Who wants it? Zoom crew, what you got? What's the y-intercept here? Don't be shy. It takes you longer to unmute. Y'all know it. Sorry, what's the slope? You got it? I can't hear you. Oh no. Things are going wrong. Huh, I should be able to hear you. Nora, what'd you say?
It's 7.464.
7.464. Okay. What does it mean in this context? The slope. Yes. It is the rate of change of the distance, or what are we doing to make that change happen? What do we do? Add a rubber band. So here we go. When we add one rubber band, the predicted distance traveled increases by 7.464 centimeters. And this is our slope here. And this is our x increases by 1. So when our x context increases by 1, the slope is that's our rate of change. This, you're going to see this context. We're going to talk about train cars. We're going to talk about airplane flights. We're going to talk about iPhones. We're going to talk about rubber bands. This is a silly example, but it sticks with you because you remember, like, as I add one rubber band to the bottom of a Barbie, which is ridiculous in and of itself, but you remember that one causes the rate of change. Okay? All right. Let's break it down. This is going to be this box is going to be divided into 3 parts. So, big ideas on this. First one, predictions. When we make predictions, we're going to use y hat. Y hat is equal to a plus bx. This is our predicted. Here's our y-intercept. Here's our slope. And you know this, but we're in a statistics context here. A word of caution down here. Be careful of making predictions based on other data. What was that called? Extrapolation. Y hat. It's literally called Y hat. No, it's literally called Y hat or predicted value. We're not fancy around here. Second chunk. Woo-hoo. Be careful of extrapolation. And extrapolation is when you have reasonable, I don't want to say like concentrated data, and then you use it to predict something that's really far away. What we're going to talk about later. We sold 20,000 iPhones on the first day of release. Oh, if we keep it up at this rate, we're going to sell 1 billion iPhones by Thursday. Well, okay, that would be nice, but we can't really predict it like that. Okay. Second piece, residuals. And residuals, and sometimes it's going to be abbreviated resid, is equal to actual minus predicted. And I remember it as RAP. Residuals equal actual minus predicted. A kind of fill in the blank sentence we might use to provide context around this. So if they ask you this, like, what does it mean to have a residual in this case? So what you'd say is the actual and in the blank goes the Y context. So in this case, it'd be like the actual distance fallen was blank, and that's where we put the residual. Higher or lower than predicted for, and this is our X context. And actually, let me make that a little bit clearer. You can say X will be expressed as a number there. So for example, the actual distance fallen was 1.347 centimeters lower than predicted for X equals 5 rubber bands. Does that make sense? So it's a way to interpret residual. All right, last piece here. Oh, notability, straightening. It's X, the number that you put in for X. So it'd be the X value, yes. In other words, it would be X value. Last piece, Y-intercept and slope. So the Y-intercept, when X equals 0, and that's going to be in context, and I guess I should be consistent with what I've been doing now. So our y-intercept means when our x is equal to 0, and you got to put that in context. So when x equals 0 rubber band, when no rubber bands are attached, our y context, which in this case was distance fallen, is y-intercept, so is 25.3333. To interpret slope, with each additional x context, the predicted y context increases or decreases by, and slope goes in there. What do you think? Does that make sense? Pretty straightforward. All right, let's jump into those same groups and go ahead, work on this this check your understanding, okay? And we'll check back in. I'm not going to move. Maybe I move. Maybe it'll move me when they jump in it. So go ahead and work on that check your understanding. You're going to be doing a little bit of equation writing, prediction, interpretation. That's pretty much the setup of an AP problem. Write the equation, find the residual, interpret. Perfect. Go ahead and do that check your understanding. Yeah. Yes. Yeah, when you finish that up, go ahead and head outside. Yeah. Yeah, go all the way down to E. Hey, we're taking a little mask break here, so please feel free to take about 7 minutes, so till 27. All right, we'll be back. back in action. All right, here we go. So let's check our answers. Let's check answers. Yeah. Why is that? A rat? You have a rat phobia?
No, like she has that.
All right, so let's talk about something really gross then, okay?
Okay, what is it?
So let's see. This actually happened twice. So at our first house, before we had Walter, I started to smell something, and I was like, "What does that smell?" And I don't have a good sense of smell. My wife does, and it was in one of the closets, and so we got air fresheners and sprayed it, and I was like, "There's something wrong here." So I went up in the attic, and a rat had built a nest right next to the air conditioning down vent, because in the winter it's warm, in the summer it's cool. So it had built a nest right there, and it was dead. Oh, it was dead, and it was a big nest. So I had to go up there. I had on a respirator and goggles, and I took a spray bottle. I go and I spray it. I sprayed it all down because you don't want everything flying everywhere, right? I stuffed it into a plastic bag, and I had to douse it with like Lysol. So I'm like, oh man, that was horrible. I'm never gonna let that happen again. So then we moved, and in that house, I started to smell something like, what the heck is going on here? So I'm like, I know the answer to this question. So I go up in the attic, I check every single one of the down vents, there's nothing. And I'm like, what's going on? I look over, and if you've ever been in an attic, you know how like the roof goes down like this? And it's like down, it's like coming down. A rat had tried to climb over one of the trusses, and it just died like halfway over it. Like it was like it made it, and then it was dead. Are you serious? Oh, this is real. I thought she was joking. I wouldn't have told the story. That's a great story. I would have held on to that. All right, go, Marley. Will you go check on her? She's go. All right. So for this, I hope that you can kind of like take a short step from what you know about linear equations into understanding predicted. So for the first one, when we interpret it, for each additional week, the predicted weight increases by 40 grams. So we've got 1 week, 40 grams. You can kind of see the danger here, right? Is there a ceiling to this? Okay. We're done. We're good. We're good. I didn't know it was real. I thought you were joking. No. It's real. All right. So when a rat's 0 weeks old, its predicted weight is 100 grams. That's the interpretation of the Y-intercept. So at 0 weeks old, when it's born, 100 grams. When the cat is 16 weeks old, this cat has a weight of 740 grams. It's a very small cat. Tiny cat. When we calculate our residual RAP, RAP, 700 minus 740 is equal to negative 40. So it's possible to get a negative value. We're going to talk about that in the next lesson. We're going to, like our next little piece of this lesson when we talk about this, but it's lower than expected. That's okay. That can happen. And then at the end, We wouldn't want to do that because that would be at 104 weeks, and this cat data is only from x equals 25 and below, so that would be extrapolation. Okay, we would not want to extrapolate like that.
Well, could it say 40, comma, grams? That's 40 grams.
40 grams, negative 40.
No, like below that. 40 grams.
The actual weight is 40 grams lower than predicted.
Oh, lower.
Lower than predicted. All right, now, go ahead and flip over to the next page. We're going to talk about iPhones, and I'm going to show you how to graph a scatter plot on your calculator again, okay? So go ahead and put this data into your calculator. We've got from the original to the 6S and 6S Plus. So go ahead and put these in your calculator again. So remember, yeah, so you probably hit delete on them. So what you need to do is you go to stats. If you ever can't find your lists, like list 1 and list 2 disappear, run setup editor, and that'll bring all your lists back. Say it again. Setup editor. So go to edit, or go to hit stat, and then stat number 5 should be setup editor. All right. Ah, yes. I am so glad you asked this question. Do we have to use the year, or should we use 0, 1, 2, 3, 4, 5, 6, 7, 8? All right. So it doesn't necessarily say, but let's use the year because it doesn't say year since 2007. So if it said year since 2007, you'd use 0 through whatever. But because it doesn't, we're going to use the actual year itself. Okay, so when you have your data in, what are we going to do with this? Do you remember? You see this yellow up here, stat plot? We're going to plot these stats. So go second stat plot. And yours is going to look a little bit different than mine. But you need to select a picture that looks like a scatter plot. So it's going to be the one with the markings. And you need to make sure that your X list is list 1 and your Y list is list 2. And you're going to hit graph. Oops. I have the benefit of having advanced technology. List 1. So how can you find this? Do you remember how you find a plot on your calculator? Go to zoom stats, zoom 9. Go to zoom 9.
Mr. Harris,
Yes, sir.
how do I make a scatter plot again? What do I have to click?
Did you follow the steps? Do you have your data?
Yes. Yeah, I have all the data in, but
Okay, so hit stat plot. So hit second and then stat plot. It should be in the upper left-hand corner.
okay.
So then select the first one. So number 1, hit enter. Grab the, or press enter on the one that looks like a scatter plot.
Okay.
Make sure your X list says list 1 and your Y list says list 2.
Mhm.
Okay, and then do a zoom 9. So hit zoom and then hit 9. Do you see your plot? Do you see the graph there? Good. 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 Okay, so now answer the question. Answer the question. Does it look linear? Linear enough. How linear is linear enough? Is the question. Well, I'm going to tell you. Mine doesn't look linear. I don't know about you, but mine kind of curves. Does yours kind of curve? So what we're going to say for this one is describe the form. What is the form? Remember, in the dust analysis, it's linear or nonlinear. What do you think, Miller? Yes. Yes, the distribution is nonlinear. Okay. So now here's the question. If it's nonlinear, what are we even talking about? Like, can we still do an analysis? So what I'd like for you to do is run the least squared regression line. Run the least squared regression line on this data. We're going to see. We're going to see it. Yeah. Okay. So what equation did you get when you ran your least square regression line? Hold on, let's start from the beginning. What does a least square regression line start with? Y hat equals. What does Y hat equal? What's your Y-intercept, Min? What's your Y-intercept? Nope, that's our slope. Negative 3,222.633 plus 1.605 x. So our predicted number of iPhones sold is negative 3,222.633 iPhones plus 1.605 iPhones times X. I'm going to rewrite this in language that I understand. Units sold, and I'm going to put the hat over that, equals negative 3222.633 plus 1.605 times the year. So predicted units sold is negative 3,222.633 plus 1.605 times the year. Okay. How do we calculate the residual for 2007 then? Somebody raise their hand and tell me, how do we calculate residual? Carson. Yeah, so you just take 2007 and plug it in for X. Here we go. So units sold predicted for 2007 is equal to negative 3222.633 plus 1.605 times 2007. What do you get? When you did that, what'd you get? Nothing. Negative 1 point what? Is that right? See, now you're all curious. So Zoom crew, help us out. They got negative 1.40 when you round. Is that what you got? Is it possible? So hold on. So before you erase that, let's just talk for a minute. Let's interpret that first. If it's right, what does residual mean? Let's write it out. The actual number of units sold is what? If we got a negative. What goes there? So what is this number here? What is the negative 1.40? Hold on. That's the predicted. What was the actual? Okay. So if residual equals actual minus predicted, what is our actual? What was actually sold in 2007? Okay. So 0.5 minus a minus 1.4 equals 1.9. So what does that mean? 1.9. Yes. 1.9 is the residual. Okay? So you got to be careful. So this is what we calculated is not the residual. The residual is the difference between the actual and the predicted. Now, when we calculate the residual, remember, it doesn't, so you're probably thinking, well, they predicted that they were going to not sell 1.4 million. Like, what does that mean? What does it mean to have a prediction that's negative? You lose money, but really that's why it's important to remember that it's predicted, because okay. Now, what we're going to do here is we're going to make a scatter plot of sorts. It's called a residual plot. What I'd like for you to do is calculate the residual for each of these, and I want to divide up the work. Okay, I'm going to divide up the work. So, Anna and Miller, you've got 2008, 2009 in the back, 2010, 2011, 2012, 2013, 2014. Zoom crew, you have 2015. Okay, everybody calculate one residual. We're going to put all of our data together. Yeah. October 6th is next Tuesday. Okay. Where's my 2008 crew? You got my numbers? Tell me what the predicted units was. 0.07. Okay, I'm going to do 0.21. And then what was my residual? Should be 0.79. Because you do your actual is 1 minus 0.21. Yes. Hey, so fill in the chart with us here. Where's my 2009 crew? 2009? 2009, what'd you guys get? 1.81, and then what was your? Okay, 1 minus 0.81 would be negative 0.81, right? Where's my 2010? What is it? Should be 3.42. That's all right. So if it's, yeah, so you do 1.605 times 2010 minus 3222.633. Yep. So then you should have gotten a residual here of negative 1.72. Where's my 2011 crew? What'd you get? 5.02. Then what? Okay, where's my 2012 crew? What'd you get? We'll go 6.63. We'll go negative 1.63. All right, 2013. 8.23 will work. What'd you get for your residual? Okay, and 2014. Perfect. Zoom crew, what'd you get for us here?
We got 11.44.
11.44. And then
1.56.
1.56. Okay. You ready here? This is beautiful. This is going to be a thing of beauty. You ready? Now we're going to do a residual plot. A residual plot has on the x-axis it's the same x-axis. But instead of plotting the y, we're going to use the residual. Now look, when you do a residual plot, 0 is in the middle. And because you can have a prediction that's too big or too small, you got to have negative, right? So this would be your actual was bigger, or sorry, your actual was smaller than you predicted. This is your actual is bigger than you predicted. Does that make sense? So when we plot this, let's take a look here. In 2007, our residual is 1.9. You're going to model it with a dot right there. And then our next one is 2008, which was 0.79. We're going to put a dot right there. In 2009, we have negative 0.81. In 2010, we have negative 1.72. 2011, negative 1.02. 2012, negative 1.63. And then 2013, 0.77. 2014, 0.16. 2015, 1.56. Okay. Make a note here. When it's above that axis, the actual was greater, right? Because residual is actual minus predicted, RAP. Actual minus predicted. If the actual minus the predicted leaves you with a positive number, that means it's greater. So where else is it greater? Yep. So over here, actual was greater. So down here, actual was less. So, do you think the regression line was a good fit for the data? What was your R value when you ran it? You remember when you made that line, what was your R value? 0.99 what? 0.995. So it had a really high correlation, right? Really high correlation. But is a line a good fit for this? No. What tells you that the line was not a good fit for this? No points on the line, okay? It's not linear. Yes, that's exactly right. So here's how you know if a least squared regression line, an LSRL, least squared regression line, is a good fit. Number one, is the data linear? If not, then no. And if yes, then look at R value. If you look at the R value first, sometimes you go, well, the R value is really high, so it must be a line. But then you look at the data, it's like, nope, it's actually not a line. So why is it so highly correlated? Well, it's the way that least square regression lines are formulated. So here's what we're going to say. And I'm going to give you a little snippet here. No. The residual plot looks curved. So the data is nonlinear. There is a positive negative positive pattern. Yeah. So positive, negative, positive pattern means there's some that was greater, less, greater. A good residual plot for a good least squared regression line has random scatter. So good residual plots show random scatter. Okay, good residual plots will show random scatter because some are above, some are below, some are above, and it's okay. It's random scatter. So sometimes they'll give you a residual plot and they say, hey, is this a good least squared regression line? And your first check does it look like a pattern? If it looks like a pattern, it's no good for a least squared regression line. It doesn't mean it's not a good fit for like exponential. This is, but it's not a good fit for a least squared regression line. Okay. All right. We did not finish the breakdown on the next page, but it's the same. It's a synopsis of that. So you'll be more than equipped for your homework. So go ahead and try the homework. What's that? The homework is, sorry, buffering. The homework is 1, 2, 3, 4, 5, about 11 problems. So some of them are different than others. Okay. So next time you're going to have a quiz on the first part. So being able to find the R value and do a Duff's analysis. Okay. Duff's analysis. Yeah. It's going to be a shorty like the Duff's analysis. Okay. So being able to do the Duff's analysis, not on this, Duff's analysis. Okay. Yes. It's bad. If the residual plot shows pattern, it's not a good line. Okay. All right. Bye, Zoom crew. See you next time.
Sirs.
Anything interesting?
I hung out with my dad. We went to my grandma's land and we like fixed a four-wheeler. My dad mowed. Just some stuff.
Just general
Yeah.
stuff and things.